Welcome back. This is Kylri Jayvel. This is Unit 5, Part 1, Developing Internet of Things, which is part of the subject Internet of Things, subject code 1590422E. This slide explains about the Unit 5 syllabus, which includes IoT platform design methodologies, IoT physical devices and endpoints, IoT systems, logical design using Python, IoT physical services, and cloud offering. We are going to see about Amazon Web Services for IoT. This slide and the next slide gives a list of Amazon Web Services we are going to consider. So let me list one by one and then give you a hint on each of it and then go in detail. The variants are Amazon EC2, auto scaling, S3, RDS, DynamoDB, Kinesis, SQS, and EMR. And now coming to the first one, Amazon EC2, the most important point to be remembered is it is a infrastructure as a service model. So if you need IaaS, then you can opt for EC2, but it does not have a scaling option. And now EC2 along with the scaling of up and down capacity is added. If it is added, then it becomes auto scaling. So Amazon auto scaling is EC2 plus scaling option. So if you need scaling, then you would opt for this. S3 is something when you need an online cloud storage infrastructure, then this will be a good choice. Amazon RDS, it provides web services in order to create MySQL, Oracle, or Microsoft SQL Server in the cloud. DynamoDB is a NoSQL database, and it is a scalable data storage for IoT. Kinesis, if you need real-time processing of streaming data, then you can opt for Kinesis. And SQS provides a queue system that stores and releases messages in a scalable manner. EMR is something which utilizes Hadoop framework for running your EC2 and S3. Let us see the explanation of each one of them. The first one in the series is Amazon EC2. I will just list you the important points of Amazon EC2. The first is it provides infrastructure as service. The second important point is it can be used as pay as you go compute capacity. And the third is the compute capacity is provided in terms of virtual machines. And point number four is EC2 can be used for several purposes for IoT systems. For example, it could be used for deploying IoT applications, can be deployed on the EC2. Usually, these applications are developed using popular frameworks like Django. And then it is also used for setting up IoT platforms with REST web services and many more. This slide explains about Amazon auto scaling. So this helps in scaling up and down on the EC2. So whenever you have spikes, you can have the increase in the EC2 instances. And whenever there is a reduced workload, you can thereby scale down. So this helps us to reduce cost to a greater extent. And now the auto scaling option can be applied for IoT applications as well as IoT platforms. And now the bottom box, which has a snippet, is just a cut copy of from the text. So I'll just tell you the basic idea of how the auto scaling process is carried out. You don't have to understand or like go through the full text. I will just give you the gist of what is happening. So the first thing which you have to do is like you have to get connected to something called as the auto scaling service. So how do you do that is you call a connect to region function. So in order to connect to the auto scaling service, and there are two arguments passed to this function in order to getting connected to the auto scaling service. So they are AWS access key and the AWS secret key. So now after you complete this, now you have to do a new launch configuration. So this is done by creating create launch configuration. You just have to call this function. And the launch configuration usually contains instructions on how to launch new instances, including details about ID, instance types, and security groups. And the next step is after you create the launch configuration, now it is that you have to get yourself associated to the auto scaling group. So for that, the auto scaling group has to be created by calling a function called as create scaling group. So this is the overall idea about how the instance gets connected onto the auto scaling cloud. The next cloud we are going to discuss is Amazon S3. This is an online cloud storage infrastructure which helps for storing and retrieving very large amount of data. The beauty about it is it can store raw data store, which is very much important in context of IoT. Because the raw data, the examples can be your sensor data, log data, image, audio, and video data. So, which is a very essential type of data in terms of IoT. And now, with respect to the installation or how to get access to this, the first thing is you have to use a function called as connect S3 in order to get connected to the service. As we saw in the previous slide, here also you pass two functions to the, I'm sorry, two attributes to the function. So the access key and the secret key. And now there are two important functions which you call appropriately. The first one is upload to S3 bucket path, and the next one is upload to S3 bucket root. So what do they do is whenever you wanted to store your file to the cloud, so whether you wanted to store it in the root or in any other path specified, accordingly you use the respective functions. And here the terminology used for storing the storage is the bucket. So that's why they use this terminology. And coming to the important points about S3, it is very highly reliable, it is scalable, it is fast, it is fully redundant, and it gives a affordable storage infrastructure, which makes S3 a good choice. This slide explains about the next possibility, which is Amazon RDS. So, in case you wanted to create instances of MySQL, Oracle, or Microsoft SQL Server in the cloud, then you can opt for RDS. It is a relational data structure. So, it takes care of most of the complexity. So, it makes life very simple for the developers. It can serve as a scalable data store, which makes it very interesting. So whenever IoT system developers wanted to store large amount of data, so they can scale up whenever they need or scale down accordingly. So there's a lot of examples available which you can go refer to. So the last line box 8.27, which refers to the Python code, is actually the one which refers from the book, which I've referred for the whole of the presentation, which I've given in the references. If you need more details, you can just go through the book, because this slide's intention is to introduce you what is what, and things like this, which are given in box 2 or the paragraph 2, is just to create more interest to the reader or the listener. So if you are interested more, you can just refer to the book and try to understand in detail. The next in the series is Amazon DynamoDB. It is a NoSQL database, and it is fully manageable and scalable, and it provides very high performance. And the IoT system developers can store any amount of data and also take up any level of requests for the data. DynamoDB is established by calling the function dynamodb.connect to region, and schema for the new table is created by calling conn.create schema. If you need real-time processing of the streaming data, then Amazon Kinesis will be the right choice, and it also helps automatic scaling, and it can be processed by any other compute instance like Amazon EC2 when connected to Kinesis, and it is well suited for IoT systems that generate massive scale of data and which has strict time deadlines in processing of the same. Kinesis also allows rapid and continuous data intake, as I've already referred, and it supports data blobs of size up to 50 KB. So the data producers write data records to kinesis stream. Data records in kinesis is referred to as shards, and a single stream can have multiple shards. And a single shard of throughput usually allows capturing 1 MB of data per second and up to 1000 put transactions per second, and the read data rate is up to 2 MB per second. So the next is Amazon SQS. The Q stands for the queuing model, which it uses for storing and releasing of messages. Listing down the salient points, it is similar to Amazon Kinesis. It is also scalable, it is reliable, and it uses a queue system that stores and releases messages in a scalable manner. So if you want to establish connection to the SQS service, you can call the method sqs.connect to region. So if you want to create a new queue, then you use create queue function, and if you want to retrieve the queues, then you use get all queues. The next is Amazon EMR. It is a web service that utilizes internally Hadoop framework running on Amazon EC2 and Amazon S3, and it allows processing of massive scale data, and it is well suitable for IoT applications, and it provides facility for generation and analysis of large volume of data, and the data processing jobs are usually formulated with map reduce parallel data processing model. So with the previous slide, it brings us to the end of understanding of Amazon Web Services. And now in this slide, we'll see about Skynet IoT messaging platform. So this is an open source instant messaging platform for IoT. And Skynet API supports both the HTTP REST and real-time WebSockets. The devices can be anything including sensors, smart home devices, cloud resources, drones, etc. And for it to work, you need to register the devices on the network. In the Skynet IoT messaging platform, each device is given a UUID, Universal Unique Identifier, and a secret token. And the devices and the client applications can subscribe to other devices, and they can also receive and send messages both ways. This slide gives us an idea of the various commands used for setting up the Skynet. So the point to be noted here is there's a MongoDB involved, Node.js involved, and there's a lot of dependencies which you have to install. So if you're interested to do a practical stuff on Skynet, then you can refer to the book which is given in the reference for more details. So all my lecture which was prepared for Unit 4 and Unit 5, the main book which is referred is Internet of Things, a hands-on approach by the authors Arshdeep and Vijay. If you need more details, kindly refer to this book. And with this, it brings us to the end of Unit 5, and we'll join soon with yet another lecture. Thank you so much.